hi, Allie, and maybe Maddie watching this video. This is 4-5. There are two sections left, 4-5, 4-6, okay? 4-5 is implicit differentiation, and I'll tell you what okay, we've been doing explicit the whole time, okay? So the 4 rules that we have been doing is explicit, okay? So explicit differentiation, I'm going to write up here at the top. Explicit, there are 4 rules to doing it. The most basic one, the one that we learned right away, was the power rule, right? We're not going to write all these, we're not going to write out the rules, but we're going to write out what their names are. Number 2, we can do the product. Okay. It doesn't matter what order we put them in. Number 3 is the quotient, O-T-I-E-N-T. And number 4 is called the chain rule. And those are all when we're doing explicit differentiation, okay? There's a difference between explicit and implicit, okay? Implicit over here, and the easiest way that I can use to describe implicit, it's not any more rules. We don't have any additional rules. We're using the same rules as before. But in implicit differentiation, you have x's and y's that are intermixed. Okay? So let me show you how this works. Do you need me?
No. Oh. So he hasn't told me yet. Girls, look at me. He hasn't told me yet. He hasn't decided if he's going to have you guys come in at 9:30. He doesn't know.
Erica told us already.
How does she know?
She asked him.
Oh, he did tell her that?
Yeah.
Well, he told me, he goes, I don't know what I'm going to do. I'll probably tell him later. He says, I'll probably have him come in at 9:30. I think he wants you guys to.
Oh, somebody let Allie know.
She's on the group chat.
Allie, they're talking about the group chat, so you don't have to be here tomorrow until 9:30. There you go.
Somebody tell Allie.
Check your group chat. I'm sure you probably have already. Okay, so
Allie,
there's that.
Watch this video. Oh wait.
Allie's not gonna watch this.
Oh wait, you're gonna watch this video
later.
If you.
Yeah.
Allie's not gonna watch this video. Well, she might.
She might.
She does.
Well,
she
we'll see. Okay, so implicit. In implicit differentiation, you have x's and y's that are intermixed with each other, okay? So let's look at the difference between implicit and explicit and how you know when you need to have them, okay? So explicit differentiation, like circle or put a box around this, okay? What we're trying to do is we're trying to find the derivative of that. And what we would do is we would probably just move x to the top like they did here and just find the derivative, right? Okay? Okay. Implicit, though, would be if the x's and y's are on the same side of the equal sign together, and it's like, how do we deal with that, okay? So implicit versus explicit, here we go, okay? All right.
I know, that's why I said I was like, okay, I want to go check.
Let's do this really quick. I'm going to have us take the derivative, and we're going to write some notational things in here. So let's say our function is y equals, I don't know, 3x squared. Let's just do that, okay? Now, the derivative of that, we know how to take the derivative of that. It's 6x, right? Okay. But what do we put on the left side?
Y prime.
Y prime, right? To note that that is the derivative, we say y prime, okay? Now, another thing that we could do is if that instead is called f of x, we would go f prime of x. That means the same thing as y prime, right? It's just f of x, right? Or another notational thing that we will do is call it dy over dx, okay? dy dx, and this means the derivative of x or of y with respect to x, okay? We're taking the derivative, like x's are like main variable, right? Maybe I'll put that in here. Like x is the main variable that we are using, right? So in other words, y prime is the derivative of y, right? Or f of x prime is the derivative of y, or y dy dx is the derivative of y. Does that make sense? Yeah. Okay, like those are the notational things that we use, okay? All right, so let's go down and let's look at an example of something more involved that would use the implicit differentiation when we have something that looks like this, right? Like I know how to take the derivative of x squared, right? It's 2x, okay? And this guy right here is going to give me a problem. I can't take the derivative of y the same way, right? Okay, so this is going to give me a problem, and taking the derivative of y, of 4y is going to give me a problem. And then I have equals, the derivative of 2 is going to give me 0, right? So this guy becomes 2x. This 2 becomes 0, but those two pieces that involve y are going to give me problems because I've never taken the derivative of y before. It's always just been the derivative of x. X is like my main variable, right? So this is when we use implicit, when we have x's and y's going on at the same time. Happy with that? Okay? I'm going to show you how this works, all right? We are differentiating with respect to x, meaning that x is our main variable. X is our main variable, okay? When we have the derivative of x to the third, it's just 3x squared and we're done, right? This is like the main thing that we're used to doing, yeah? Okay, let's go down to like c now. Here is what this derivative is going to look like for c. Are you watching? Here we go. The derivative of x plus 3y. Ready? X plus 3y. What's the derivative of x?
1.
1. Okay, now here's what we're going to do. Every single time we take the
Oh my gosh,
derivative
is it
of
backwards?
y, no.
Okay.
Every single time we take the derivative of y, we treat it, we do the same thing as what we would do for x. So like if that said 3x instead, what would the derivative be?
It would
3x.
It would just be 3, right? It would just be 3, right? Okay, but
Don't
since
write down.
we're taking the derivative of y, it's still 3, but every time we take the derivative of y, we have to tack on dy dx because the derivative of y is dy dx, okay? And I set up above, Ellie, you were gone, but dy dx is, says the derivative of y with respect to x. Okay, dy dx is saying the derivative of y with respect to x because we can only take the derivative of one variable. But if I have x's and y's intermixed, this is just saying, hey, x is my main variable that I'm taking the derivative of, right? Okay, so x can stay 1, like we don't have to put any extra fancy things in there, but anytime y is involved, we have to tack on dy dx at the end, right? Okay, so let's go up here and let's do like the derivative of this guy. So y to the third power. Okay, if we
but why
take
does
his
it-
derivative, okay, hold on. If we take the derivative of y to the third power, don't worry about this notation. This is
No,
just
I'm
saying take the
worried
derivative.
About everything on that
Okay,
side.
so y to the third power would be 3y squared, right? Like if we do it like we do x's, right? The 3 comes
Yeah.
down in front, we subtract 1, but
dy dx.
whenever we take the derivative of y, we have to tack on dy dx. That's it.
What does this mean?
What?
Why is it the dy dx this thing?
What are you talking about?
The brackets.
Oh, right here? Right here? This part on the front?
Yeah.
This part on the front? This
No,
is just
the whole stuff on this side of the equation.
on this side of the equation?
Yeah.
Okay, what that is just saying, that is just the notation that they use for saying, this just says, take derivative of this with respect to x. D over dx is just saying the derivative with respect to x. Does that make sense? The derivative with respect to x. That's just the command that we're doing, right? That left side, by using that notation, they're just saying take the derivative with respect to x, but you're doing it to y to the third power, okay? So now, this is the ugly part, D. This is really ugly, and this is where you're gonna be like
I
really
don't want
sad
it.
for this, okay?
Okay, wait.
Aw.
Can we do it separate or do we do it together?
What?
Are they trapped together?
Just wait. So, x y squared is what we're taking the derivative of. X times y squared, which is a
Something stupid.
product, which
No.
means we have to do
No.
the
No.
product
No,
rule.
we can't
Yeah, we
because
do.
this is implicit.
Yeah.
We don't want to do that.
No, we have to do the product rule because you still use the same rules for implicit, right? Okay. So product rule is f prime g plus g prime f. Okay, and then I'm gonna write below it my little bubbles. So bubble, bubble, plus bubble, bubble. Okay. All right. So in this case, what is the f part?
X.
X, and the g part is y squared, right? We like separate them out like that, right? So f prime would just be 1, right? G would just be y squared. So 1y squared, done, right? But g prime, though, I'm taking the derivative of y squared, which is 2y, but I have to tack on dy dx. Anytime we take the derivative of y, we have to put dy dx on there to note that that's not my like specified variable. Okay, we're taking the derivative with respect to x. And then f is just x, right? Okay, then we simplify him. 1 times y squared is just y squared plus, and I'm going to put all that stuff together. Ready? This is how I'm going to do it. 2xy dy dx. That's how I'm going to do it. Okay, I'm going to put the x before the y, right? I'm just combining all that stuff together. I usually have dy dx as my last little piece, and that's all we're going to do. What?
Can you add the y squared to the others?
No.
Okay.
Nope.
Why not?
Nope. So we just have those two pieces. That's it. Okay? Good? All right. I know this is going to seem kind of foreign, but you know, it's going to get better. Okay? Let's go down here and let's do something like this. Okay? Find dy dx. Okay? Now we have a really ugly thing right here. But the really nice thing is we have no product rules. Do you see that? There are no product rules in there. So
What
this
do you
is just
mean?
the straight, like there's no products, right? Like this is its own piece. This is its own piece. There's no x's and y's together, right? Those are just all pieces by themselves, okay? Now, here's what this is going to look like, because we haven't done this before, okay? There is an equal sign here, okay? So we're going to do some solving. They want us to find dy dx, okay? Find dy dx. All right, so we're going to do each piece individually, just like we do with the x's. The derivative of y to the third power is 3y squared, but
dy dx.
dy dx, okay? Now we move on to the next piece. The derivative of y squared is 2y dy dx, right? We have to tack that on there, okay?
Made it like a prettier way to write it.
I know.
Minus 5 dy dx.
Minus 5 is the derivative of 5y, but we need to tack on dy dx. Okay, minus 2x. Okay, now, before we move on, okay, 2x, technically, this guy does get one of these on the end of him, right? Okay, but what will his label be?
dx dy.
Dx dx, right? But what is dx over dx?
Oh,
Nothing.
1, right? So technically he does have dx dx. The whole time he has, right? Anytime we take the derivative with respect to x, he does technically have a dx dx, right? But dx dx is 1, right? Because it reduces. So that's in a sense why we don't put a dx dx on the end of it, right? Like there's no reason, because it just reduces to 1, okay? So that just becomes 2x, and then the negative 4, he becomes 0. Okay, now we're not done yet.
Yeah, we
Okay,
are.
here we go. They're wanting us to find what? dy dx, okay? How many terms do you have going on in this whole big long thing? Technically 5, including the 0 on the left side, or on the right side, right? So we have 1, 2, 3, 4, 5, okay? What I want to do is I want to get all the dy dx's by themselves, right? So this guy involves a dy dx. This one has a dy dx. This one has a dy dx. I'm going to kick the 2x to the other side, right? Okay? So I have equals 2x because I'm adding the 2x over, right? Do we see how that works? Okay? And I've got all that junk. You know, if you want to rewrite it, you can. If you don't want to, you don't have to. What?
Can we put them together?
Was it like parentheses and dy dx at the end or no?
That's what we're going to do.
Mm.
Yeah. So I'm just rewriting, okay? You are so smart, okay? What we're going to do is, since all 3 of the terms on the left side now have a dy dx attached to them, we are going to pull the dy dx, and I pull it up front. You can put it behind, it doesn't matter. I'm going to pull it out front. So I'm going to say dy dx. I'm going to take each one of those out in front, right? So if I drag that out in front, 2x is just chilling on the right side. He will look like 3y squared plus 2y minus 5. Do you see how we did that? We pulled it out of each term.
Did you divide it?
Yeah, then we're just trying to get dy dx by itself. See, look at you guys. Look at you go. So we're going to divide
2x divided
by this, right? I'm just going to do that. Blah, 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 divide by that. So dy
y minus
dx equals 2x. We're just dividing this thing over 3y squared plus 2y minus 5. Okay? And what this says is the derivative of this whole big long thing is equal to this. Yeah,
I don't like that.
I know. Okay, good?
It's not so bad.
Happy with that?
It's not
We've
terrible.
done
enough.
worse things.
Yeah, it's not too bad. Okay, now let's go to example 4, where it says find the slope of the tangent line to the graph of that function at this point. Okay? I'm going to circle this, what we're trying to find. Find the slope of the tangent line. That's what we're solving for. Is she okay in there?
I think so.
Yeah.
But that was like 10 minutes ago.
No. You wanna go check on her?
Is she vomiting or what is she doing?
No, she was just in the bathroom, but
Okay. Okay. We'll go check on her here in a minute. We're almost done.
I think she's.
In just a little bit. Okay? All right. Okay, find the slope of the tangent line. What's another name for slope of tangent line? Derivative. Derivative is equal to the slope of the tangent line. So this is just saying find the derivative to the graph of this at the point, this thing. So now we have a point.
It's not a function though.
It's a circle.
It's a circle. It doesn't matter. It doesn't matter. You can still find derivatives even if it's not a function, right? Like what they're saying is find the slope of this line right here when it's touching that dot, right? Find that slope. It's going to be a positive slope, whatever it is, right? So we're just going to find the derivative and we're going to plug our points in, right? Okay? So starting with, I'm going to rewrite x squared plus 4y squared equals 4. We're going to find that derivative and we're just going to plug points in, okay? So derivative of x squared, 2x, technically dx, but we don't put that on the end, right? Plus 8y
dy over dx
dy dx equals 0. Okay,
That
now what?
To the other side. So
Now
it's
move what to the other?
2x.
2x is, okay, minus 2x minus 2x.
dy dx equals negative 2x. Divide by 8y.
Okay, divide by 8y. Yep, you got it.
y dx
Okay, and reduce.
equals 1/4.
Negative?
One
I'm going to
fourth.
say negative x over 4y. Can I do that?
1/4.
What scent do you have?
Birthday cake.
What they do?
Okay, so this is the derivative. This is the derivative. The derivative is this thing, right? That's what that's saying, okay? And now we want to find the actual slope, what that's going to be. So we're going to plug numbers in. And we have now in implicit, normally when we're finding derivative, when we're plugging stuff in, we only care about plugging the x in. But now we do have to plug a number in for the y, right? Because we have y on our thing. Okay, and this is going to be kind of ugly, but it simplifies really nice. So negative square root of x over
Square root of x.
4 times.
What are you doing?
Oh, square root of 2. Blah, blah, blah. I can't math. I can't write things, right? Square root of 2, right? That's what we're plugging in for x, yeah? Over
Negative
4 times negative
1.
1 over the square root of 2. Okay, so let's simplify some stuff. Okay? All right, so on the bottom, we've got 4 over 1, right? Okay, let's do that to start with. Okay, so I'm just going to let this negative square root of 2 chill on the top, right? Okay, on the bottom, what will we have if we multiply by 4 over 1?
Negative 4 over square root of 2.
Negative 4 over the square root of 2. Okay. All right, if I make that top square root of 2 as a fraction, he's like the square root of 2 over 1, right? You see that? Okay, now I can keep flip, right? So I have negative square root of 2 over 1 times negative square root of 2 over 4, because I flipped it, right? Does that make sense?
Yes.
Okay, now the negatives are going to cancel out, plus, right? What's the square root of 2 times the
4.
square root of 2?
2.
2 over 1 times 4, which is
2 over 4 equals
4,
half.
which is 1/2. What does that mean?
That's the slope.
That's the slope of what?
The tangent line.
Of this tangent line, right? This is going up 1 and over 2 as we go through there, right? That's the slope of the tangent line. Yeah. And we
was
did that
tricky.
implicitly. It wasn't too bad. Like if it had a really nice point to plug in, that wouldn't be really bad. Even the implicit part was not hard to find. It was the plugging in the point that was probably the
We
hardest.
have a fire
Okay.
weather watch.
Okay. What time do we get out of here?
And 4 days.
In what?
Soon.
Okay, let's do this last example and then we'll be done. Because we're not going to do example 6, okay? Find the tangent line to the graph of this thing. Ugh. This is my original function.
The graph does not really matter.
I mean, the graph does, like,
Oh, it does?
tells me, yeah, the graph doesn't really matter. But we're finding the slope of the tangent line at this point, right? So when we plug it in, we know that our answer should be probably like a positive number, right? Because the slope is going uphill, right? So after we plug this in, we should end up getting a positive number. So we have to find the derivative of this thing.
2x.
Hold on.
But
Hold on.
First, you have to distribute.
Or
We
can
can distribute it.
over?
So we have options here, right? We have options here.
I'd rather
We could
distribute-
do
I'd rather
we could do the
distribute
product rule where this is my f
them.
and this whole thing is my g, right? Okay?
Just distribute first.
Or we could distribute first, but okay, let's distribute first. X to
Can't we
the
just
4th
divide
power,
the
hold
whole
on,
thing over?
Oh wait.
plus x squared y squared. And if we do that, we're still going to have a product rule, right? Like this is still going to be a product rule.
Okay, so we
But
don't have
which
to.
product rule is uglier?
Oh, Jake would not do that.
The first product rule or after we multiply it through?
After.
I feel like the second one's uglier, but
You feel like the second one's uglier?
I don't know. You're the teacher.
Because they only have after. Well,
Well, we get rid of
I
the X
almost
out
think
of
that
the
I almost
front.
think if we distribute it through, then it's maybe easier. Let's go ahead and distribute it through. Let's go ahead and distribute it through. Okay, let's do it. Okay, so x to the fourth, he just gets treated like normal. 4x cubed, right? Okay, and now we have to do our product rule. So this guy times this guy plus this guy times this guy. Okay,
Wait,
f prime
what?
g
Wait,
plus g
whoa.
prime f equals. So this guy becomes this guy, right? Because we have to do the product rule. Yeah? Do you see what I just did? Yeah?
So
Yeah?
the
Okay.
x squared is f and the y squared is
The x squared is f and the y squared is g. Yep. Okay, let's go ahead and do the y squared on the end, right? This is 2y dy dx, right? That's what he is. Yeah?
Ew, I don't know.
Okay. So there's that. All right, now let's do the other stuff. So f prime, he will be 2x, right? Okay. G is just y squared, right?
What's F and what's G?
F is this guy, G is this guy, right? F is this, G is this, yeah? That's my product. That's what I'm multiplying together, right? I'm multiplying x squared and y squared. So that's my product. Okay?
Don't you need a dx and or dy?
No, that's for G prime.
That's for G prime, when we're taking the derivative of G. So G,
2y dy dx.
2y dy dx. Okay? And F is just going to be x squared. Okay? Good? Blech. All right, so let's do this. We've got 4x cubed. Let's simplify our parentheses here. That doesn't look like a 3, but anyway.
2xy
Plus
squared.
2xy squared. Plus, I'm going to write it as 2x squared y dy dx. Yeah, because I like to put it in that order. Equals 2y dy dx. Okay? How many pieces do we have right now?
Too many.
1, 2, 3, 4. Okay, what's the next order of business?
I don't know.
I want to get the dy dx's together and the other stuff together, right? So that one has a dy dx. So I'm going to move him onto the back, and he's going to be minus 2x squared y dy dx. You see that? I just moved him over. Okay, so pretend he's not here. All right, so I have these 4 pieces, this one, this one, this one, this one, right? Okay. Are we okay so far?
Yeah.
4x cubed plus 2xy squared equals, and I'm going to pull that dy dx out. And I have left over 2y minus 2x squared y, yeah? Like that?
Yes.
Okay, now I'm going to divide him over. So 4x cubed plus 2xy squared over 2y minus 2x squared y equals dy dx. Okay, and that's my derivative.
Can we just leave like that?
Hmm.
That was the icky
But then they want us to plug this thing in.
Yeah, well, we get out now.
Can we just like not plug it in and pretend that we did?
Yeah.
Right? Okay. So we would plug them in, but we are not going to for right now. Okay.
Work day tomorrow because we're gonna have like 20-minute class periods.
Sure.
Great.
Yep. Do you want me to give you your paper now though?
You already did.
I did already. Okay. So you can take, and there's only 6 questions. So
Texted me telling me to
yay.
get Hubbles, so I'm gonna go.
The next one, right?
Okay. Perfect.
I don't know why.
Okay. Goodbye.